Hey everybody, so in this video I'm going to be running an example on a diode circuit, and then eventually we're going to find these currents, I1 and I2. But first, we have to figure out which of these four assumptions is the correct assumption. We're going to have to eliminate three, and then we're going to have to be ending up with one that works. So let's just begin with each one, or before, let me go over the rules. So you either have, the diode is binary. It's either on or off, just like a switch. So if it's on, that means it acts like a wire, a short circuit, right? And it's conducting current. So the current has to be greater than zero, can be equal to or less than zero. That's when it's on. So then when it's off, okay, right here, when it's off, you replace the diode with an open circuit, so an open wire. That means no current flows through it. The current has to be equal to zero, right? And then the anode, okay, so I didn't mention this. So here you have a diode, okay? This side right here is the anode, and this side right here is the cathode. For it to be on, this side of the anode has to be positive, and this side of the cathode has to be negative, right? Because current flows through it. Current flows from positive to negative. That's when it's on. But when it's off, the anode has to be negative, and the positive has to be, the cathode has to be positive, right? When it's off. So let's just run an example. Let's just run an example right here. So this is the circuit that we're going to be analyzing. And let's just go through each of these four assumptions. See, these are the four possible assumptions. If you only have one diode, you have two possible assumptions. You have either it's on or it's off. Okay, but when you have two diodes, you're then left with four. Either both are on, both are off. First one is on, the second is off, or the first one is off and the second is on. All right, so let's just begin with these four assumptions. We're going to first assume that both diodes are on. If both diodes are on, that means both are replaced with a wire, so a short circuit. If that's the case, so here I'm going to redraw the circuit. You have a 12-volt battery right here, DC voltage. Okay, then you have the resistor. Okay, replace the first diode, diode 1, with a wire. And then you have the 4-volt. Okay. And then diode 2 is also replaced by a short circuit, a wire. Okay, so you have the 4 ohm here, the 4 ohm here. Okay, alright, so let's take a look at this case. Here we have a short circuit, a wire. And this wire is in parallel with this side and this side, right? And the definition of a short circuit, a wire, what it does, it's gonna have the current flowing through it instead of this branch and this branch. And because of that, that means the current flowing through where the first diode was, right here, is zero. But we assume both are on, that means both should be conducting current. But due to this short circuit, the current going through diode 1 is zero. And that contradicts with our assumption that both are on. For that reason, we can eliminate the first assumption that both are on. It just can't be the case. Okay, so let me redraw the second assumption right now. So the second assumption is that, or you know what? Okay, so we eliminated the first one. Let's move to both are off. Okay, oops. So both are off. Let's try this one. Both are off. If both are off, that means both should be replaced with a open circuit. All right, so open circuit like this, open circuit. And then we have the 4-volt battery. Okay, and then here also replaced with an open circuit, and then we have the resistor. Okay, 4 ohms, 4 ohms. So what I'm going to do right now, okay, to test this assumption, I'm going to run a KVL loop around this first loop here. So that would be 12 minus, the voltage across the 4 ohm resistor is 0 since there's 0 current due to this open circuit. All right, and then we have a 4-volt here. So from positive to negative, we're moving this way. Positive to negative, that's a minus 4 volts. All right, and then, the KVL has to be equal to 0. So where's the other remaining negative 8? And that comes from the switch. So there's a voltage across the open switch or the open circuit. So we need a negative 8 here. And for that to be the case, if we're moving in this orientation, okay, you need to have a positive here and negative here, because when you go like that, you have from positive to negative, that's a negative, and 8 makes this entire equation equal to 0. And if that's the case, right, remember when there was a diode here? The anode, this side, the anode is positive, and the cathode is negative. That means it's conducting current, but our assumption is saying that it's off. That means no current should be going through this. And for that reason, we can eliminate that assumption that both are off. We just proved that it can't be the case. So we can eliminate this. Okay, and let's try that diode 1 is off. Well, since we proved that the first diode can be off, remember when I did that KVL, that means this assumption that says diode 1 is off and diode 2 is on is wrong. I'm not saying that diode 2 can be on. I'm just saying that since one part of this entire assumption is wrong, the entire thing is wrong. So we're left with this last one right here, this last assumption that diode 1 is on and diode 2 is off. And it has to be right because we've eliminated all those others, but let's just go ahead and prove it. If you're on a test running short on time, you don't need to prove it. After you've eliminated the 3 and you're left with 1, just go with that if you're short on time. But let's just prove it in this case. So here we have the 4 ohms. Okay, we're assuming diode 1 is on. Okay, wire. And then we have plus, minus, okay, the 4 volt DC. And then we have here replaced with open circuit and then the 4 ohm. Alright, so what we have right here, okay, so diode 2 is off. If we run a loop around this right here, we get, what do we get? We get, okay, 12. All right, the current across the 4 ohm resistor is 0 due to this open. Or not necessarily, we have to find the current going through. Let's find the current going through. The current going through this branch not necessarily is 0. Just we know the current going through here is 0. So we need to find the current going through this 4 ohm resistor. We could do a KVL loop inside here, and that would just be 12 minus 4i. Okay, so 12, let me zoom in, 12 minus 4i, all right, and then minus 4, because of this, equals 0. So what would that leave us? It would leave us with I equal to 2 amps, right? So now we're going back to this entire KVL loop. We get 12 minus 4 times 2, because there's 2 amps going through here. That's 8. And then, okay, so it has to equal to 0. And then we have another 4 volts, a negative 4 volts remaining. That has to come from the open switch. So we need to have a positive here and a negative here for it to have a negative 4 volts. Because remember, we're going from positive to negative. That's negative 4. So that has to be the case. And if we look at the orientation of this diode, it has the anode on this side, and the anode's negative, and the cathode is positive. That means it's not conducting current, and that's our assumption. We're assuming that diode 2 is off. That means it's not conducting current, and that's the case. You know, for it to be conducting current, the anode side, this side, has to be positive, and this side has to be negative. But that's not the case because it's off. So we've proved that that's right. And for that reason, that leaves us with this being our only assumption. And now let's solve the last part of this problem with solving for the currents. So I1 and I2. So we have to redraw this current according to this assumption. We have 12 volts here, 4 ohms. Okay, so diode 1 is on, wire. Okay, and then diode 2 is off, so I'm just going to skip that because it's an open circuit. And then we have the 4 ohms. So what we want to solve for okay, is this current, I2, and this current, I1. Well, it's the same right here, whatever. It's the same along this branch. So it doesn't matter if I put it here or if I put it here. Anyways, since we found that the current going through this branch here is 2 amps, right? So that means we have current here going 2 amps. All right, and then we have here, I'm going to call that I2, and here I1. Okay, so let's just do a loop. I'm going to do an outer loop, okay, an outer loop. That is 12 minus, okay, the current, 4 times the current going through, that's 8, minus this 4 ohms times the current, I2, equals 0, right? That means I2 is equal to 1. So this right here, I2 is equal to 1. And now if we just do KCL, okay, the current law, we have 2 going in equals to I1 going out plus I2 going out, and I2 is 1. That means I1 is equal to 1. So we've solved the two currents. I1 is equal to 1 amp, and I2 is equal to 1 amp. And that sums up.